Hello everyone, in this video we are going to share our result of Proximate analysis in cream crackers hot snack. Before that, let me introduce our members. I am Anis, there is Juhada, Adriana and Ridwana. Next, I am going to explain what is Proximate analysis. Proximate analysis is a systematic approach used to determine the composition of food by breaking it down into its fundamental components such as moisture, ash, fat, protein, and carbohydrates. This method provides essential information about the nutritional value and quality attributes of food, which is crucial for food labeling, formulation, and regulatory compliance. By knowing these values, manufacturers can better formulate their products to meet specific dietary needs or guidelines. Additionally, this information helps in making informed decisions for consumers regarding their diet. Okay, now let's move on to the objective. First, the objective of Proximate analysis is to determine the basic nutritional composition of a food sample. Second, to assess the quality and value of food products for human consumption or industrial use. Lastly, to provide essential data for food formulation, labeling, and nutritional evaluation.
The Proximate composition provides an overview of the basic nutritional content of the sample analyzed. First, we have moisture. The moisture of the sample is 3.02%. The low moisture content indicates that the sample is relatively dry, which enhances its shelf life and reduces the risk of microbial growth. Next, we have ash. The result is 3.48%. This represents the total mineral contents. The moderate value suggests the presence of essential materials beneficial for health. Other than that, we also have fat that 28.3% in the sample. The high fat content shows that the sample is a rich source of energy and may contribute to flavor and texture. Other than that, we have protein that 8.37%. The protein level indicates a fair contribution to body building nutrients, making the sample a moderate protein source. The carbohydrate, we have 56.83%. Carbohydrates make up the largest portion, serving as the main source of energy in the sample. So as a result, as a conclusion, the total of all the source is 100%. This confirms that all components collectively make up the entire sample composition. Overall, the result shows that the sample is energy dense with a balance of carbohydrate and fats, moderate protein content, and low moisture for better storage stability. We go to the next slide. The table shows a comparison between the experimental values obtained from laboratory analysis and the nutritional information provided on the product label. First, we have protein. As we can see, the result we get in laboratory is at the left and the value in packaging on the right. So first we have protein. The result we get is 8.27%, and the result the value on the packaging is 8.4%. The experimental protein content is very close to the labeled value, indicating consistency and reliability in protein analysis. Next, we get fat. Fat that we get in laboratory is 28.3%, which the result on packaging is 29.4%. The fat content show a slight decrease compared to the label, which may result from variation in sample handling or natural difference in composition. We also have carbohydrates that the laboratory result is 56.83% and the value in label is 66.6%. These carbohydrate levels are nearly identical, showing that the carbohydrate estimation align well with the labeled data. We also have energy that we get in the result we get in laboratory is 515.5 kcal or 100 gram, which the result the value in packaging is 513 kcal or per 100 gram. The calculated energy value is slightly lower than the labeled value, which correspond with the minor difference observed in fat and protein content. So for overall, the small variation between experimental and labeled value are within acceptable limit, demonstrating that the laboratory result accurately reflect the nutritional composition of the product. This confirms good quality control and consistency in the product formulation.
Now, let's move to our discussion. Based on our experimental result, the protein content of the biscuit sample was found to be 8.37%, while the nutritional label state 8.4%. The protein content was determined using the Kejida method, which measured the total nitrogen in the sample. In biscuits, protein plays an important role in building and repairing body tissues and supporting overall health. When we compare the experimental value to the label value, we can see that they are almost identical with only a small difference of 0.03%. This shows that our experimental procedure was accurate and the product label provides reliable information about its protein content. Now, for fat discussion, for the fat analysis, the experimental result showed a fat content of 12.45% compared to 12.5% on the nutritional label. The determination was done using the Salt-Slag extraction method, where fat was extracted from the biscuit using a solvent such as petroleum ether. The residue left after the solvent was removed represented the total of fat content. When comparing both values, the difference is only 0.05%, which shows that the experimental procedure was accurate and the nutritional label is trustworthy. This also indicates good accuracy in our fat determination process. For fat discussion, the biscuit sample show an ash content of 1.23%, while the nutritional label indicate 1.2%. The ash content was determined using the dry ashing method, where the biscuit sample was heated in a muffle furnace at around 550 degrees until all organic matter was burned away. The remaining residue represented the total mineral content. Ash input represent the total mineral present such as calcium, iron, and potassium, which are important for maintaining body function and health. Our experimental value was identical to the label value with only 0.03 difference. In this proof that our experimental value was almost identical to the label value with only a 0.03% difference. This proved that the analysis was precise and the label information reliable, reflecting good accuracy in our experiment. Next, for this part of our analysis, we focus on determining the moisture content of the biscuit sample. Our experimental results show that the biscuit contains 5.32% moisture, while the nutritional label provides a manufacturer state 5.3%. To obtain this value, we use the oven drying method, which is a common and reliable technique for measuring moisture content in food products. In this method, the biscuit samples was heated in an oven at 105 degrees until it reached a constant weight. The idea behind this procedure is simple. As the sample is heated, water evaporates, and the loss in weight corresponds to the amount of moisture present in the sample. Once the weight stopped changing, we could assume that all the water had been removed, and we use the weight difference to calculate the moisture percentage. When we compare our result to the nutritional information on the packaging, we found that we found that our experimental value 5.32% was almost identical to the lab value of 5.3%. This close agreement demonstrates that our experimental technique was both accurate and precise, and the manufacturer's nutritional information is reliable. The very small difference of only 0.02% may be due to minor experimental factors such as environmental humidity, sample handling, or measurement rounding. However, this difference is negligible and does not significantly affect the result. Lastly, we determined the carbohydrate content of the biscuit sample. Our experiment showed that the biscuit contains 72.63% carbohydrate, while the nutritional label indicates 72.6%. The carbohydrate content was determined using the different method. In this method, we first measure the percentage of other components such as moisture, protein, ash, and fat, and then subtract their total from 100%. The remaining percentage represents the total carbohydrate content of the sample. This method provides an indirect yet effective estimation of carbohydrate composition. Carbohydrates are a major micronutrient in biscuits, contributing significantly to their energy value, sweetness, texture, and overall taste. They play a key role in giving biscuits their crispness and desirable mouthfeel. When comparing our experimental result of 72.60% to the lab value of 72.6%, we can see that there is only a tiny difference of 0.03%.
So hi, next I will explain about some challenges and errors that may occur during Proximate analysis. First, human or personal error such as inaccurate weighing, pipetting, or misreading instruments, scales, and timers. Second, instrumental error, which happen when equipment like the oven, balance, or substrate is faulty or not properly calibrated, or when there's inconsistent temperature or voltage supply. Lastly, sample preparation error, which includes incomplete drying or breeding that causes uneven sample and possible contamination during handling or transfer. So, next I will explain about the impact of proximate analysis. It helps determine the nutritional value by identifying key nutrition like protein, fat, carbohydrate, fiber, moisture, and ash. It also ensures quality control, keeping food composition consistent and up to standard during production. Besides that, it evaluates processing effects, showing how drying, heating, or storage can change nutrients level. And lastly, it supports product development by helping create new food products with specific nutrition content. Overall, proximate analysis is essential for maintaining food quality and nutrition accuracy. That's all from me.